Okay, so in part two, we're going to describe how to graph each of the following functions that are written symbolically. Now, the way you want to do this is by using transformations. So you're going to notice that when we do these, you're going to graph each transformation that's going to occur. And it needs to be done in a very strategic way. So one of the things you got to remember and remember, this is part two. So in part one, that we did this in a previous lesson. So this was part one, and then today we're going to look at part two. So one of the things you got to remember, though, is that from previous lessons we did talk about, and these are going to be important as we work through these. But we did talk about vertical translations. We talked about horizontal translations. We talked about what the notation looks like. How to get from the point on the basic graph to the new point, and we talked about reflections over the x-axis, reflection of the y-axis, and so forth. We looked at vertical stretch, shrink, horizontal compression, which is the same thing as shrink, and horizontal stretch. So these are things that you may need to review as we go through this process. When you are graphing these, though, if you're given a function that's written symbolically and you want to graph those, it must be done in a certain order. And the order is this. So the transformation you do first must be the horizontal translation. Then you do the stretch or shrink. And then you do the reflecting, and then the vertical translation is always done last. Okay, so it must be done in that order. If you don't do it in that order, you're graphing the graph you get is not going to be for the function you want. Okay? All right, so let's look at number one. And so number one, you have, and this is part two. So in letter A, you have 8k of x is equal to 1/3 absolute value of x minus 4. Okay, so 1/3 absolute value of x minus 4. So remember, the first thing you got to do is you've got to find out what your basic function is. Now remember, the other word for basic function or basic graph is your parent function. So your parent function here is that absolute value function. So your parent function, your basic function, is and we're going to call, remember, we call these different names because these are different graphs. So y1 is going to be your parent function. So we'll call this absolute value of x. So remember, when you graph this, we use the t-table, and so you may recall that when we use the t-table, and we substituted x 0 for x, the absolute value of 0 is 0. So that was one of our points we used. And remember, the domain here is all real numbers, so it really didn't matter which point we used for x, which real number we used for x. But what we did, though, was we used integers. So if x is 2, I got y, the absolute value of 2 is 2. If x is negative 2, I got the absolute value of negative 2 is 2. We also could say if x is 5, we get the absolute value of 5 is 5. If x is negative 5, we get the absolute value of negative 5 is positive 5 as well. Okay? And so we plotted those points. And so we plot those points. So that will be step one. So step one, remember, you must say those in steps. So you guys say step one, graph the basic function. So you must say that. And so your basic function, you'd say y1 equal absolute value of x. And so you go to your coordinate plane and you graph the absolute value of x. So remember, the absolute value of x is at v. Okay, so really all you need are 2 points on either side, and you got your graph. So 0, 0, and then 2, 2, right? And then let's do 4, 4. And over here we had negative 2, 2, and then negative 4, 4. Okay? And so I'm going to draw my graph. And so remember, that's that the absolute value, the graph of an absolute value is at v. And so the vertex is at the origin. Just like that. And again, you have to say this, you got to tell me what that equation represents. So that's y1 equals absolute value of x. Okay? All right, now the next thing we have is this. So notice that I have a vertical. Now, is this going to be a vertical stretch or shrink? So remember, the absolute value, if the absolute value of this is less than 1, we have a shrink. So what that means is that I'm moving this graph, I'm compressing this graph towards the x-axis. So it's going to look wider. All right, so all these points I'm moving towards the x-axis. Okay, so you're going to see what that's going to look like. Okay, so step 2 is this then. Step 2 is you got to say like this. You got to say vertically shrink, or you can use the word compress. It's not a stretch. Remember, a stretch is where this is bigger than 1. So a stretch is where you're moving it away from the x-axis. So you're pulling it away from the x-axis, so it makes it look skinnier. All right, this is a vertical shrink, a vertical compression. So you got to say vertically shrink, and you say this right here, vertically shrink y1 equals absolute value of x by a factor of 1/3. Okay, so by a factor 1/3. All right. Now, so and when we do this, you're going to get your second transformation, which is y2 equals 1/3 absolute value of x. So this is this part right here. Okay, so remember what that means. So whenever we vertically stretch or vertically shrink, we're moving each point on the function. We're either moving it up or moving it down by a certain factor. Okay? And so whether you go up or down, you'll notice that the x value stays the same. It's the y value that changes. So you may recall that when we looked at our rules in previous lessons, that when we have a vertical stretch or vertical compression, the x values stay the same as the y value that change, and they change by multiplying the y value by, in this case, the factor, which is 1/3. Okay, so basically what we have to do here is see this point right here, that's negative 4, 4. So if you think about this, negative 4, 4 becomes what point? Well, the x value stays the same. I take the y value and I multiply by that factor. So multiply by a factor 1/3. So 4 times 1/3 is 4 1/3. I'm sorry, 4/3, excuse me. 4/3, which is 1 1/3. All right, so 1 1/3. So that's 1 1/3. So this point, negative 4, positive 4, becomes negative 4, 1 1/3. 1 1/3, which is about here. And so at this point, I already have this part of the graph now. See how it compressed towards the x-axis? So I have this. Okay, so I'm compressing this graph towards the x-axis. And so on this side, do the same thing. So we see how we had 4, 4. Well, 4, 4 becomes 4 what? 1 1/3. So do the same thing there. So the absolute value is easier to deal with. All right, so we get this. All right, so what I have here is this. This becomes y2 equals 1/3 absolute value of x. And then finally what I got to do now is I've got to vertically translate this down negative 4. So your next step, and you got to say this, so you got to say step 3. Step 3 is you're going to shift this graph vertically, or you can just say down 4 units. All right, and when you do that, you're going to get your final graph that you want. So you just rewrite this over. So we get k of x equals 1/3 absolute value of x minus 4. And so basically all you do now is just this. You just take these points here, and absolute value is easy because you don't, remember these are two rays, so you just need 2 points to this one, 2 points to that one. So you just shift it down, what was that, 4 units? So you take the vertex, 1, 2, 3, 4, just like this. And then here, you see how this does not lie on a grid line? So you just got to estimate. So you're going to shift this down. So what I would do is I would see how this is a full unit right here. I would do this from here to here. 1, 2, 3, 4, but then I go a third up again. So right here. Okay? So you see what I did? 1, 2, 3, 4. But my point here is a third above this one. So I put a third here. All right? And do the same thing here. So do the same thing, and I get this point here. Okay? And so then you draw your graph, and that is the final graph. All right, so notice though, in each case, you have to list all the transformations. You have to list all the transformations, and each case you got to tell me the equation of each of those graphs. All right, and so then this one's going to be, and this was k of x. So k of x equals 1/3 absolute value of x minus 4. All right, so let me just, before we go to the next one, make sure I wrote this. Okay, so I did the third one. All right, so step 3. All right, let's look at part B now. So part B, or letter B, we have this. We have the function h of x equals -3 absolute value of x plus 4 minus 5. All right, so there's a little bit more involved here with this absolute value. Okay, so let's look at this. So notice that I have a reflection, and notice that the negative's on the outside, so it's a reflection across the x-axis. If I take the absolute value of this, that's 3, so I'm going to have a vertical stretch, I have a horizontal translation, and I have a vertical translation. Okay? So again, my parent function, you got to look at the parent function first. So step 1, graph the parent function. So your parent function is y1 equal absolute value of x. All right, so we go ahead and we do that, just like we did the previous one. So when I do that, I get 0, 0, 1, 1, 2, 2, and so on, right? Okay, and so this right here is the absolute value of x. All right, and you got to make sure you label this. You're going to say y1 equals absolute value of x. So that's the equation of that graph. And so that's the first thing I did. Now step 2. Now you got to remember, you have to remember your steps. So first thing you got to do is that horizontal translation. So I do have a horizontal translation here. That's this. But you got to remember, you got to do counterintuitive of what you think when you see horizontal translation. So I don't go 4 units to the right. I go 4 units to the left. Okay, counterintuitive. So step 2, you're going to say just like this. You're going to say I'm going to shift this graph, my parent function, to the left 4 units. So you're going to shift to the left 4 units. And when I do that, I'm going to be graphing y2 equals absolute value of x plus 4. So all I'm doing is graphing this first. Okay? All right, so all I do is I shift every point to the left 4 units. And remember, these are rays, so you just need to shift, you just need to plot 2 points. You got to do the origin of the vertex, though. So 1, 2, oh, is it, let's see what it is again, 4 points, 4 units, right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, oh, we did this one. So 1, 2, 3, 4. All right, so we just needed 2 points on either side, 2 points on the ray. So I get something that looks like this. All right, and then make sure you indicate what that equation is. So that's y2 equals, and that was the absolute value x plus 4. Okay. All right. Now, what we're going to do next is, remember, we have to do a stretch or a shrink next. Do I have one of those? Yes, I do. So that's this right here, the absolute value though. So the absolute value of that is 3. All right, so that's a vertical stretch. So what that means is I'm taking the red graph now and I'm stretching it away from the x-axis. So it's going to make it look skinnier. Okay, make it look skinnier. All right, so remember what we do though. So the way you're going to write it is you're going to say this. So step 3, you're going to say vertically stretch. This right here, y2 equals, that's the value of x plus 4 by a factor of 3. All right, now what that means, remember what that means is that if you look at each point that's on this graph right here, y2, that's on the y2, you are taking each point and you're multiplying by a certain factor to stretch it. So each point is going to be moved up somewhat by a certain factor. Okay? And so notice that if I take this point here, move it up by a certain factor, the x value stays the same. It's the y value that changes. And so to get that new y value, I multiply this y value by that factor, and that factor is 3. So it kind of corresponds to our rule that we learned previously. So whenever we have a vertical stretch or vertical compression, remember the x value stays the same. I take that y value multiplied by a in this case. All right, so my y value here, a in this case here, my factor is 3. All right, so when I do that though, I'm going to get my third graph, which will be 3 times the absolute value of x plus 4. All right, so let's do this. So remember, all we just need are 2 points. So let's look at this. So negative 6, 2 becomes what point? Negative 6 what? So I take that y value, which is 2, multiplied by 3. So negative 6, 2 becomes the point negative 6, 6. So that's this right here. Negative 6, 6 right here. Okay? And it kind of makes sense because remember, you see this distance right here? This distance is 2 from the x-axis, right? 2 units. So if I multiply that by 3, I get 6 units, and that's what this is. Okay, so over here, if I look at what point do we use here? That was negative 3, 1, let's say. So negative 3, 1 becomes what point? Negative 3, 1 times 3 is 3, right? So that's this right here. You could have used this one. It doesn't matter, right? Negative 2 becomes the point negative 2, negative 2, positive 6, correct? All right, and so, oh, by the way, the point negative 4, 0, where's that? That stays on the x-axis because the y value is 0. 0 times 3 is still 0. All right, so then I graph that and see how skinnier it became. All right, so I get something that looks like this. Okay. All right, so this right here is y 3 equals 3 absolute value of x plus 4. So that right here, here's a graph. Notice I stretched it so it looks skinnier. When you stretch it away from the x-axis, you're pulling it away from the x-axis, it gets skinnier. Notice that this right here is this part here. So I got to do the reflection next, and then finally the vertical translation. So what happens now is this. So you see this blue graph right here, the one we just did, y3. Okay, that's this. Okay. All right. So what I'm going to do now is I'm going to reflect it. Now, when I reflect it, I want you to notice that this right here is a reflection about the x-axis. So basically what that means is I'm going to take this graph and I'm going to reflect it about the x-axis, and I'll get something that looks like this. Okay? So it'll look like this down here. All right, so that's what happens when you reflect it across the x-axis. Okay, so let's write that down. So remember, you got to write your descriptions. So step 4 is you're going to reflect this right here, y3 equals 3 absolute value of x plus 4 across the x-axis. And so when I do that, I'm going to get a new graph that we're going to call y4, and it will be this one. All right. So the negative, that's a reflection across the x-axis. So remember when you reflect something across the x-axis, see this point right here? What changes? What stays the same? You agree the x value stays the same, right? What changes the y value? They become opposites. So this point here, right here, when I reflect it across the x-axis, becomes, that was what, 6, 2? So it becomes the point 6, negative 2, correct? All right, so remember our rule, when we reflect something across the x-axis, reflect over the x-axis, the x values stay the same as the y value that became opposites. All right, so what you need to do that one is see this point here? That is negative 6, 6. When I reflect it across the x-axis, what does it become? Negative 6. The y6 becomes y negative 6. So 6, negative 6 is here. Okay? The point negative 4, 0 becomes negative 4, and what's the opposite of 0? It's still 0. Over here, this point here, there was 3, negative 3, 3. Negative 3, 3 becomes negative 3, negative 3, right? And so if I draw this, and let me use a different color. Let's see, I'm running out of colors. Let me use green. So if I do this, I get this. Okay? So this right here so that right here is that reflection. So remember that was the one where we had this, and then I was going to reflect it about the x-axis, and I get this. Okay? So that is the reflection. So that would be y4, which equals negative 3, absolute value of x plus 4. Okay? All right, now, okay, so now what we want to do is the next part, and the next one is a vertical translation. So remember that's intuitive here, so that just means I go down 5 units. So I'm going to take this graph here, the green one, and remember what's happening is this. So I'm going to take this, and we go down 5 units. So my final graph is going to be this. Go down 5 units. What's the vertex? 1, 2, 3, 4, 5. So I should get something that looks like this. Okay, down here. All right. So let's write the description. So your description, you're going to say this. You're going to say step 5. So step 5 is you're going to shift this graph, y4 equal negative 3, absolute value x plus 4, down, and it was 5 units, so down 5 units. And then when we do that, that is the final one we have to do, so I'm going to say we're going to get this now. So we're going to get, we get h of x, which is negative 3, absolute value of x plus 4, minus 5. And so all you do is just take these points, some key points here, And these are absolute values, so it makes things a lot easier. And you just shift it down 5 units. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the same thing here. 1, 2, 3, 4, 5. And then you just connect those. You draw your V. And I get something that looks like this. And then once you do that, though, you have to tell me, remember that's a final one, so you got to give me that the name of the function as well that was given. So that was h of x. So you got to say h of x equals, and then negative 3 times absolute value of x plus 4 minus 5. Okay? And so it does make sense. I'm going to just double check to make sure that it matches up, and it does. Okay, so that is letter B. Okay, so that was B. So notice all the things you had to go through. So you got to show all this. So you got to make sure that all those transformations that need to be done are done just like this. All right, and you got to make sure you for each graph you do, you got to tell me that the equation it represents. Okay, so that was letter B. All right, let's look at C. So in C, you have this one in C. So C is this. So C, find it was okay. Here's C. So key is k of x is equal to 1/3 times x plus 5 squared plus 4. So 1/3 x plus 5 squared plus 4. Okay, so the first thing you're going to do, remember, the first thing you always have to do is graph the parent function. So what's the parent function here? Your squaring function. So it'll be x squared. So you're going to graph the parent function first, which is y1 equal x squared. So real quickly, you know what that looks like. So you go to your graph paper, and make sure you have graph paper. Otherwise, if you do this by hand, it's really going to be bad. It's going to be messy, and you're not going to truly understand what's going on. So the grid paper is in Canvas, so make sure you print it out. Okay, so we're graphing x squared. So 0, 0, 1, 1. When x is 2, y is 4. When x is 3, y is 9. Okay, and then the same thing here. Negative 1, 1. Negative 2, 4. Negative 3, 9. So this is the graph of x squared. Okay, so that's the first thing you have to do. Then once you graph it, you got to label it. So this is my parent function. I'm going to label it y1 and say x squared. Okay. Then let's see what we have next. So then we have a vertical shrink. We have a horizontal translation. And we have a vertical translation. So we have three things. We have three transformations. So what's the first thing I do? The horizontal translation. So remember, it's counterintuitive. So do I go 5 units to the right or 5 units to the left? I go 5 units to the left. So the way you're going to write it, you're going to say this, step 2. You're going to say shift y1, which equals x squared, to the left 5 units. So to the left 5 units. And so all you do now is this, and it's easy to deal with. So every point you just shift to the left 5 units. Now remember, this is not an absolute value, so you do need to be dealing with more points. So I'm going to darken our key points. So here, 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 here. And let's do these two since that's within our plane. So all those points I've darkened, those key points, I'm going to shift 5 units to the left. Okay, so watch. 1, 2, 3, 4, 5. So there's my vertex, my new vertex. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now this point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I draw my parabola, and I get something that looks like this. Okay. Now, once you draw it, you gotta tell me the equation. So what this equation, remember, if we write it out, so that's going to be y2 is, remember, this is the part I'm doing right here. So you're going to say y2 is x plus 5 squared. That's what this is. Okay. So you're going to say, right here, you're going to say y2 equals x plus 5 squared. All right. Now, what I have next to do is this. I have a stretch, a vertical shrink, and then a vertical translation. So I do the shrink. So what that means now is this, that the graph here is going to be compressed towards the x-axis. So it's going to make it a little bigger, right? So you're compressing it. So all of these points that are on this graph, you're going to shift them towards the x-axis by a certain factor. All right, and remember, you're going to do that. The x value stays the same. You're going to do that by multiplying the y value by that factor. All right, so let's talk about that. So, step 3. So you're going to vertically shrink. Now make sure you use the correct word. Don't say stretch, because if this is bigger than 1, if the absolute value is bigger than 1, then it's a stretch. This is less than 1. So it's a shrink. So vertically shrink. This right here. y2 equals x plus 5 squared by a factor of 1/3. Okay? And when we do this, we're going to get a new graph that looks like this. 1/3 x plus 5 squared. So see this right here? So this is where I'm at now. Okay, so what you do, remember, each y value you're going to multiply by 1/3. All right, so let's think about this. So you see this point right here? This point right here, that is the point -8, 9, right? So let's think about this. So -8, 9, so -8, 9 becomes what point? So when, remember, you're shrinking it, so you're moving it down. So the x value stays the same. It's still going to be -8. But to get that new y value, you take this y value, which is 9, and multiply by our factor, 1/3. Well, 9 times 1/3 is 3, and so that goes here. So I'm going to put the point -8, 3. So -8, 3 is here. Okay? So it kind of makes sense, because see, this distance here is 9, so if I take 1/3 of it, I get 3 units. Okay? All right, let's look at this point. So this is the point -6, 1, right? Right here. -6, -6, 1. Okay? So let's look at that. Let's think about that. Well, if that is -6, 1, -6, 1, it becomes -6, and then I say I take the 1, I take 1, multiply by 1/3. So what's 1 times 1/3? 1/3. So that becomes the point -6, 1/3. So -6, 1/3 is about here, right? And then the point -5, 0, -5, 0, so -5, 0 becomes the point -5, and what's 0 times 1/3? Well, 0 times 1/3 is still 0. So it stays on the x-axis. And then notice the symmetry. So the point -4, 1 is going to be -4, 1/3, and the point -3, 4 is going to be, let's do that one. So let's look at this point here. So this is the point -7, 4, right? -7, 4. So if I look at -7, 4, so that's going to become the point -7, and I take 4, multiply by 1/3, so that's going to be 4/3, which is 1 1/3. Okay? So that's going to become the point -7, 1 1/3. So that's going to be -7, 1 1/3, which is about here. So over here, that's going to be -3. 4 becomes -3, 1 1/3. So then you just draw your graph, and it looks something like this. Okay, something like that, right? Okay, so that right here is y, let's see, this is 2, so it'd be y3. So y3 equals 1/3 times x plus 5 squared. So that's what that is. So y3, so we get this. So y3 is this. Okay? And then finally what we're going to do is we're going to take this now, so we only have one thing to do. So we're going to take this and we're going to shift it up 4 units. So that's a vertical translation. So remember, vertical translation is always last. So basically, we're going to take this right here. So I didn't draw this very well, but see how it overlaps almost? So we're going to take this, we're going to shift it up 4 units. So 1, 2, 3, 4. So this will be the final graph. So the final graph is going to look like this. Okay? All right. So let's shift all these points up 4 units. So I'm going to use, let's see if this is going to work, this color. Okay, so go up 4 units. 1, 2, 3, 4. Go up, let's start here, here. 1, 2, 3, 4. Now let's talk about this right here. See how this is not quite on a grid line, but this is what, 1 1/3? All right, so let's think. 1 1/3, I'm shifting it up 4 units, right? So I'm adding 4 to it. So 1 1/3 plus 4 is 5 1/3. Y'all agree? So 5 1/3, so here's 5, so that's about here. So this, when I shift it up 4 units, gets this. Okay? Here, that's 1/3. Right here, the y value is 1/3. Well, what's 1/3 plus 4? Well, that's 4 1/3. So here's 4, and 1/3's here. Same thing here. So this will be a negative 4 1/3, and this will be negative 3, 5 1/3. All right, and what else am I missing? Okay, so, and then I take this point here and move it up 4. Okay, see this right here? Move it up 4. 1, 2, 3, 4. Okay, so something is off a little. Maybe that's why I didn't align very well right here. Okay, so that, yeah, that's where I messed up. So see where I had that point right here? Right here? It should have done this. Okay, so let me go back here. So I had right here, I had used 8. It should have been 9, right? Okay, so that was a mistake I made. So 9 times, I can fix it right now. So this was a point negative 3, 9. And I don't think I had it anywhere. So negative 3, 9 becomes a point negative 3, 3. Oh, I did have it, didn't I? Yeah, right here. Okay, so let's do this again. This point here, this point right here. So that's the point negative 2, 9. It becomes a point negative 2, and what's 9 times a third? 3. So it becomes a point negative 2, 3. So my mistake was I put 3 in the wrong place. This is where 3 is, right here. So it really should look like this, okay? That's what it should look like. And so real quickly, I'm just going to quickly take this part off right here. Okay, so that's what that looks like. And now let's do that next one. There was one more I had to do. So I moved this up 4 units, this up 4 units, this up 4 units, this up 4 units, and then this has to be up 4 units. 1, let's see, 1, 2, 3, 4 right here. Okay, so now I get this. Okay, so be very careful when it gets so cluttered like this. You can easily kind of mess up right here because there's so many points in your vision. So just be careful. So this is where I had messed up. I put the point in the wrong place. So that's why it didn't match up very well. But look at this real quickly. So notice that I had to take this right here, right? Take this right here and then shift it up 4 units. 1, 2, 3, 4. And I get this. Okay? So you got to tell me what this is though. So this right here is, that's our final graph, which was this. So k of x equals 1/3 x plus 5 squared plus 4. Okay? All right, so it can be very cluttered. So be very careful as you go through your thinking process, and be careful, because even I will make mistakes sometime where you put the point in the wrong place and it kind of throws you off. Okay, so that is letter C. All right, now let's look at letter D. So letter D, you're dealing with the cubing function in letter D. So you have this. You have g of x equals -1/2 x cubed plus 2. The problem with the cubing function is that when you plot x cubed, when you graph x cubed, there's not that many key points you can use because you're cubing that, and so the y value gets big. In the graph we're using, it only goes up to 11. So it's 11 by 11. So this is 10. You can go up to 11. So there's not many key points you can get with x cubed. But the first thing you're going to do though, still, is you're going to, step 1, you're going to graph the basic function. And the basic function, or the parent function, is y1 equal x cubed. Okay, so let's think about the points we're going to use here. So if I look at x cubed and I let x be 0, 0 cubed, 0 times 0 times 0 is still 0. If I look at 1, 1 times itself 3 times is still 1. If I look at -1, now remember this is -1 cubed. -1 cubed means -1 times -1 times -1, which is a -1. If I look at 2, 2 cubed is 8. And we'll look at -2. -2 cubed is -8. -2 times -2 times -2. And that's, in terms of integers, that's about as far as I can go with regard to this plane. Because if I go any further, like let's say 3 cubed is 27. And I don't have enough room to plot 327. Okay? So that's about all I can use. So when I plot those points, I have 0, 0, I have 1, 1, I have 2, 8. Okay? And then I have -1, -1, and I have -2, -8. So you'll notice most of the times in the problems that you may see, you'll rarely have to graph transformations using x cubed, because it just takes up so much space in terms of your length right here. There's not many key points you can use. But the graph looks like this. So it kind of flattens right here. It looks like it's flat. So, but I'm not going to do a very good job doing this. So you get something that looks like this though. All right, on that side and on this side, you get something that looks like this. Okay, so I'm going to go ahead and widen this image. And so this is what x cubed looks like. Looks something like this. Okay? So you get something that looks like that. So this is y1 equal x cubed. So that's the first thing we did. All right, now remember, these are the key points we use right here, right here, right here, right here, and right here. Okay? All right, now let's look at the next thing we have to do. So step 2, and the good thing about this one is that you don't have many transformations to do. You have a reflection, you have a vertical shrink, and then you have a vertical translation. You always do the vertical translation last. You don't have any horizontal translation. See, the only thing that's being cubed is x. All right, so there's no horizontal translation. So in terms of what we our steps, then what's the next thing we're going to do? So we know we don't have any horizontal translation, so we do have a shrink though. So let's do that. So step 2, so the absolute value of negative 1/2 is 1/2. So step 2 is I'm going to vertically shrink y1 equal x cubed by a factor of 1/2. By a factor of 1/2. Now remember again, what that means is we're shrinking, right? So what that means is that this point, I'm vertically shrinking. This point I'm going to move down. This point I'm going to move down. This point, remember you're moving it towards the x-axis. So this point is below the x-axis, so move it towards the x-axis. So to go up. This point's going to go up. Understand? So you're kind of like another word for shrink is compressing. So you're compressing it. So you're moving this towards the x-axis. You're moving this towards the x-axis. Okay? All right. So remember what happens when we vertically shrink or vertically stretch. The x value stays the same. It's the y values that we multiply by our factor. Okay, so the point 2.8. So if you think about this, the 0.28 becomes, remember the x values stay the same, I take the y value and I multiply by my factor. My factor is 1/2. So that becomes 8 times 1/2 is 4. So that becomes a 0.24, right? So 24 is here. It kind of makes sense because what's that distance right here? That distance is 8. So if I take half of that, I get 4. Okay, from the x-axis. All right. If I have the 0.11, the 0.11 becomes what point? 1/2. 0, 0 stays 0, 0 because remember, all right, so remember we have the 0.11. So 1 becomes 1, and then 1 times 1/2 is 1/2. And then 0, 0 becomes 0, 0 because 0 times 1/2 is still 0, right? Okay. And then using that same idea, the point -1 becomes -1 1/2. So you see how it moved up? These moved down. This one's moving up. You're going towards the x-axis. And the point -2, -8 becomes -2, -4. And so you get something that looks like this now. So this is the graph. This is the graph. Y2 equals what was that, 1/2? 1/2 x cubed. Okay, so that's y2 equals 1/2 x cubed. So let's go back to our description, make sure we wrote everything correctly. So step 2, we vertically shrink by a factor of 1/2, and we get this. We get y2 equals 1/2 x cubed. Okay, a couple more things and we're done. So the next thing is to reflect this graph, the one we just did, by across the x-axis. Now, you do see that we did do a compression, right? So I'll move this graph, and I move the parent function towards the x-axis. Now we're going to reflect it across the x-axis. So we take this, reflect across the x-axis, take this, reflect across the x-axis. So do you see that this part here that's in the first quadrant, when I reflect across the x-axis, is now going to be in the fourth? This point here, which is in the third quadrant, when I reflect across the x-axis, is going to be in the second quadrant. Okay? All right. So remember, when you reflect across the x-axis, remember what happens. When you take a point here, let's say -6, 2, reflect across the x-axis, you get 6, -2. So the x values stay the same. They're both 6s. The y values are opposites. So that goes back to our rule. Remember, reflection across the x-axis. So when you reflect across the x-axis, the x values stay the same. The y value became opposites. All right? Okay, so let's go ahead and use that now. So this point here, that is 2, 4. When I reflect across the x-axis, it becomes 2, -4. Right? This point here, which is 1, 1/2, when I reflect it across the x-axis, becomes 1, -1/2. 0, 0 stays 0, 0. So this side becomes this, right? Okay, so this reflected across the x-axis. Now let's look at this one. So this point here, which was negative 1, negative 1/2, becomes negative 1, positive 1/2. And this point here reflected across the x-axis, so that point, negative 2, negative 4, becomes negative 2, positive 4. So I get something that looks like this. Okay, so this right here is y3 equal negative 1/2 x cubed. So y3 equal negative 1/2 x cubed. So this right here, so step 3 is, that's a reflection. So you reflect y2 equals 1/2 x cubed across the x-axis. So we get y3 equal negative 1/2 x cubed. And so that's what this was. And then finally, the next thing we're going to do is we're going to shift this graph now up 2 units. So step 4 is to shift this graph up 2 units. And then we get our final graph, which is what we wanted. So we're going to call it that. So we get g of x, which equals negative 1/2 x cubed plus 2. So g of x equals negative 1/2 x cubed plus 2. All right, so what's going to happen now is this. So let's go ahead and graph this. So what's going to happen is this. So that's going to be the blue graph. The blue graph will be our final graph. So I'm going to take this point here. Remember that's this right here. So I'm going to take that point here. I'm going to shift it up 2 units. 1, 2. Take this point here, shift it up 2 units. That was 1/2. Okay, so it'll become 1, 2 right here. Don't forget the this point here. Shift it up 2 units also. So that's this. Shift this up 2 units. So that's going to be negative 1/2 plus 2 is 1.5. So that's right here. So it's getting a little messy. And shift this up 2 units. 1, 2. You get this. Okay. So that's going to look like, and it's getting messy. So that's going to look like this. Okay. And so this right here is our function, which we call g of x equals negative 1/2 x cubed plus 2. So yeah, it got a little messy. So x cubed gets messy, and we also saw, depending on what your transformations are, the others can get messy too, right? Okay, so that is part 2. So hopefully between part 1 and part 2, you have enough information, you gain enough knowledge to understand the process you're going to go through when a function is given symbolically to graph it. So again, it's very important you know it must be done in this order. If it's done symbolically, if you're given to it symbolically, it must be done in this order. Okay? All right. So that's going to be the end of part 2.